Welcome to 1000 Why Questions. Here we dig into everyday mysteries you've always wondered about. You're driving home after a summer storm. The sky's still gray, your wipers squeak, and suddenly you spot it. A bright arc stretching across the clouds. For a second, everything feels calm and magical. But what exactly makes that glowing band appear out of nowhere? We've all had that moment, pulling out our phones trying to capture the colors before they fade. Red, orange, yellow. And somehow it always feels lucky. But deep down, there's a science story happening in that light. Kids say it's magic. Poets say it's hope. Meteorologists, they know it's physics playing tricks on your eyes. The real question is, why do we see rainbows at all, and why only after it rains? Think about it. Rainbows never show up at noon, and you can't chase one down. Ever wonder why it seems to follow you but never gets closer? That's because it isn't really there in the air. It's happening inside your eyes. So today, let's break down this colorful illusion. We'll go inside a single drop of rain, follow sunlight as it bends, bounces, and splits, and see why your eyes turn it into a perfect arc. Here's what's going on. Every raindrop is like a tiny glass prism. When sunlight hits it, part of the light bends as it enters, reflects off the back, and bends again as it exits. That double bend spreads white light into colors. Different colors bend by different amounts. Red bends the least, violet the most. That's called dispersion. So every drop sends each color in a slightly different direction, like a natural color sorter floating in the sky. But you only see one rainbow, right? That's because your eyes line up with millions of raindrops reflecting the same color toward you. The person standing next to you, they're seeing their own rainbow from a different set of drops. That's why you can't chase one down. It's not sitting in the sky waiting. It's geometry between you, the rain, and the sun. Move your head, and your rainbow shifts with you. The magic angle is about 42 degrees between your line of sight and the sunlight behind you. At that angle, red light reflects straight into your eyes, followed by orange, yellow, green, blue, and violet stacked below. So if the sun's high overhead, that angle never hits your eyes. No rainbow. That's why you see them in the morning or late afternoon, when the sun's lower on the horizon. Scientists have studied this for centuries. In the 1600s, Isaac Newton proved that white sunlight holds all the colors we see. By shining light through a glass prism, he recreated a rainbow in his lab. Today, NASA satellites use the same light-splitting idea to study Earth's atmosphere. By analyzing how sunlight scatters, they can tell what gases and particles are floating around up there. Rainbows are nature's version of that experiment. Harvard researchers have even modeled how our eyes detect those colors. They found our retinas respond most strongly to green and yellow light, the middle of the rainbow, because that's where sunlight carries the most energy. That's also why photos never look quite the same. Cameras and screens compress the range of brightness your eyes pick up in real life. The result? Rainbows on screen always feel flatter than the one you see outdoors. The air matters too. After a storm, the air is full of clean, round raindrops, perfect little prisms. If the drops are uneven or too small, like in mist, the colors blur into pale arcs or even a faint halo. And yes, sometimes you'll spot a second, fainter rainbow above the main one. That's sunlight bouncing twice inside each raindrop. The order of colors flips, red on the inside, violet on the outside. Beyond that, scientists have captured triple and even quadruple rainbows with specialized cameras. They're rare, but they prove how perfectly predictable the math of light really is. But here's the weird part. The rainbow you see doesn't actually exist anywhere you could touch it. It's a projection created by your eyes and brain interpreting light angles. It's kind of like a personal hologram. Your brain builds it from the specific light hitting your eyes. That means two people standing side by side are each seeing a completely different rainbow. Even airplanes show the trick. From above the clouds, pilots sometimes see full circular rainbows around their plane's shadow, called a glory. It's the same light geometry, just without the ground cutting it off. Artists and psychologists think that's part of why rainbows feel emotional. Your brain loves symmetry and bright contrast. It releases a mini burst of dopamine, the same chemical that lights up when you spot something beautiful. So the awe you feel isn't just poetic, it's literally chemical. A natural hit of joy mixed with surprise, tied to a color pattern we almost never see all at once. That might explain why we link rainbows with hope. After a storm, when the sky clears and sunlight breaks through, your brain connects that fresh burst of color with relief and renewal. It's nature's way of saying, hey, the chaos is over. Look up. The science creates the art stirs emotion. It's the perfect blend of physics and feeling. So, to recap, sunlight hits raindrops, bends, reflects, and spreads into colors. Your eyes catch the light at just the right 42-degree angle, and your brain paints that glowing arc we call a rainbow. It's part physics, part perception, and part emotion, all rolled into one brief moment after the rain. No two people ever see the same rainbow, yet it connects everyone who looks up. Next time it rains, don't rush indoors. Stand still for a minute. If the sun's behind you, look toward the fading clouds. You might just catch that quiet, colorful reminder of how light and water dance together. Makes you wonder, right? If sunlight and raindrops can create that much beauty from pure physics, what other invisible patterns are we missing in the world around us? Thanks for watching. If you enjoy small, everyday science like this, stay curious. There's always another why waiting just beyond the next cloud. We hope you enjoyed this episode of 1000 Why Questions. Don't forget to like, subscribe, and share to support the channel. Got a thought or your own why question? Comment below. And if you want more,